Now let's understand shorthand notation. Like, how can you write a shorthand notation given two half reactions? So we can say that we have these two reactions, zinc giving zinc ion plus 2 electrons, and the cell potential is that. Then copper ion plus 2 electrons giving copper, and the cell potential is that. So how can you now calculate, or how rather can you write the shorthand notation? So shorthand notation follows this format. You need to start with what is occurring at the anode, then you put these two parallel lines, then you write what occurred at the cathode. So this is how you should write a shorthand notation: anode, two parallel lines, then what is occurring at the cathode. So let's write the shorthand notation for this particular reaction. So every time you're writing the shorthand notation, you must always start with the electrode, okay, and end with an electrode. So you must start with electrode and also end with the same electrode. So you must start with electrode, end with electrode. So basically that's okay. So let's now write the shorthand notation. We've explored the format is anode, two parallel lines, then cathode, and we must start with the anode, then we go to cathode. Okay, so what occurs at the anode in a galvanic cell or voltaic cell is oxidation. So we must check which reaction is undergoing oxidation. Okay, so if we check in this particular reaction, we can see that for a galvanic cell we always get a positive cell potential. Now in this particular question, we can say that zinc has a negative cell potential, so we must swap that reaction. It will be zinc 2 plus, to be zinc 2 plus okay, in fact this is not even necessary. You must just look at the way zinc is written. So if we swap this reaction, we'll discover that in this reaction zinc is undergoing oxidation, then copper is undergoing reduction, copper is being reduced. So to write the cell potential, we'll start with always the electrode at where oxidation is taking place. So we're going to say zinc, then we put 1 line, and the state is a solid there. Okay, it is a solid. Then we can go to the one which is undergoing oxidation. It is zinc ion. So we write now zinc ion 2 plus. So we put 1 line to represent or to separate the electrode from the ion. Then we put, and the state symbol is aqueous there. Then we put these two parallel lines to separate the two cells, since a galvanic cell is always made up of two cells, okay, and they are connected by a short bridge. So then you start with what is undergoing reduction, so it is copper 2 plus. Okay, we put this is in aqueous. We put one line to separate the copper from an electrode, which is copper. That is an electrode, and it is in a solid state. So we started with this is an electrode. That is also an electrode there. So this is basically how you write the shorthand notation for any given reaction. Now let's say there were two similar states. For example, let's say we had maybe this reaction, then this was in aqueous, then plus hydrogen ion. Let's say even this was in aqueous, then let's say plus 2 electrons, then giving let's say chromium ion, 3 plus there, which is in aqueous, then plus water, H2O, which is in liquid. Okay, then you have been asked to write the shorthand notation for this reaction. So we can see that everything is in aqueous. Okay, we will start with what is undergoing oxidation, because that is what is on the anode. Then we go to what is undergoing reduction. Okay, so you can see that since they are in similar states, so the electrode we need to put there is an inert electrode. You can use platinum. Platinum is an inert electrode, so you can start with platinum. You say platinum, a solid, then you put one line to separate with what is undergoing oxidation. So what's the reaction at the anode, so you write it like that. Now for this one, to separate these two, you don't need to put or write rather the two lines. You need to put a comma because these two are in similar state. Then you write hydrogen ion. Okay, then you put another comma. Okay, all these are in similar state. Then you write chromium ion, because all these are in aqueous. Even this is in aqueous, this is in aqueous. Then you put another line, then the other side you have also platinum as an inert electrode. Okay? So basically this is how you can write a shorthand notation for this particular reaction.